Hey everyone, welcome back to Context Window. I'm your AI host, and today we're diving deep into the Model Context Protocol, or MCP. We've processed the architectural roadmap for the agentic era, and we're ready to show you why the future of AI isn't just about models that talk, it's about models that can finally act.
So let's just jump right in. You ever stop and think about how early AI, with all its incredible intelligence, couldn't actually do anything? I mean, it could write a poem or explain a super complex scientific theory, but it was basically trapped, stuck in this kind of digital solitary confinement, totally walled off from all your apps, your files, the real world.
And that leads us perfectly into our first section, understanding AI's digital prison. To really appreciate how big of a deal MCP is, we've got to first understand the problem it was built to solve.
See, the thing you have to get is that a base language model is basically a closed-off system. It's like a brain in a jar, completely frozen in time. Its knowledge is just a snapshot from whenever its training data was collected. The very first attempt to break it out was a technique called tool calling, where developers would literally handwrite descriptions of what a tool does and feed it to the AI.
But oh man, this approach was so fragile. Imagine you've got this super smart robot and you give it a really detailed manual for one specific microwave. It's great at it, follows every step perfectly, but then you take the microwave away and put a toaster in its place. The robot is just stuck. It's completely lost because its whole universe was defined by that one specific manual. Well, that's exactly what that early tool calling was like.
And this is where things just got chaotic. Every AI company, OpenAI, Google, you name it, they all had their own special format for these manuals. This created what developers call the M by N problem. If you had M AI models and you wanted them to use N different tools, you had to write M times N custom integrations. It was a total maintenance nightmare, it just couldn't scale.
And this table really shows you the tale of two worlds. On the left, you've got the old way, messy, model-specific code trapped in that N by N nightmare. But on the right, you see the MCP philosophy, a universal, open standard where you build a tool one time and it just connects everywhere.
So all that chaos and fragmentation created the perfect opening for something new, a standard that could fix the mess. And that's where MCP comes in, as the universal connector. Before we get back to the tech, think about your desk just a few years ago. You probably had a junk drawer full of different cables, right? A big one for your monitor, a different one for your keyboard, another for your hard drive, and a completely separate one for your laptop charger. It was a disaster. And then USB-C showed up and gave us one single, clean, universal standard that just works for everything.
That is exactly what MCP does for AI. It's the USB-C moment. It created a common language, a universal protocol that lets any AI application, we'll call that a host, connect to any tool or data source, we'll call that a server, instantly. No custom code, just one standard to rule them all.
So, how does this thing actually work? Well, if you look under the hood of the agentic era, you'll find this really elegant three-part architecture.
Okay, first up is the host. This is your command center, the main app that you're actually using, like VS Code or Claude Desktop. The best way to think about it is like a video game console. It's the box that runs the game, in this case our AI model, and it handles all the connections to the controllers and everything else. Now, working inside that host is the client. And the client is the real workhorse of this whole setup. It's like one of those universal translators from a sci-fi movie. The AI thinks in big ideas, right? Like, I should check the recent sales numbers. But the server only speaks in very specific database language. The client is that critical translator sitting in the middle, making sure they can talk to each other.
And that brings us to the server. These are small, specialized apps that offer up specific tools or data. Imagine you have one of those modular robot toys. You can snap on a drill arm to do one job, then pop it off and click in a gripper arm for something else. Each MCP server is like one of those specialist arms designed for one thing, whether it's talking to GitHub, sending a Slack message, or just reading a file from your computer. And to make this all work, MCP uses three core building blocks, or primitives. First, you've got resources. This is just passive data the AI can read, kind of like a student going to a library shelf to look something up. Then you have tools. These are active things the AI can do, like a chef in a kitchen deciding to use a whisk to mix eggs. And finally, there are prompts. These are basically instruction manuals, like Lego blueprints, that you give the AI to guide it through a really complex task.
But as MCP just exploded in popularity, a whole new problem popped up. It
was a classic case of success creating its own challenges, and it needed an even smarter fix.
So here's the kicker. Giving an AI access to 1,000 different tools sounds amazing, right? But in reality, if you describe all 1,000 of those tool manuals in every single message, you completely overwhelm the AI's short-term memory, what we call its context window. It made the agent super slow, expensive to run, and honestly, a lot of the time they just got confused.
The solution, which came out in late 2025, was just beautiful. It's called Dynamic Tool Search. Instead of giving the AI all 1,000 manuals, you just give it one tool, a search tool. So now when a task comes up, the AI uses that search tool to find only the specific manuals it needs for that one job, and it downloads them just in time. This one idea cut down the data sent to the AI by up to 90%. Just incredible.
And there was another cool innovation called code mode that helped with efficiency. The old way of doing things was like a head chef yelling instructions one at a time to a line cook. Go to the fridge, now grab the onions, now chop them up. It was slow and it was so chatty. With code mode, it's like the chef just hands the cook a complete recipe card. The cook does all the steps on their own and just brings back the finished dish. It's way, way more efficient.
Now, all these technical improvements are awesome, but what really sealed the deal for MCP becoming the foundation for the future was a really smart move that had nothing to do with code and everything to do with trust.
In January of 2026, Anthropic did something kind of radical. They gave the entire protocol away to the Linux Foundation. This created a new, neutral, nonprofit home for the standard called the Agentic AI Foundation, or AAIF. And that meant MCP wasn't just an Anthropic thing anymore. It was now an open, industry-wide standard, backed by competitors like Google, Microsoft, and OpenAI.
And this timeline just shows you how fast this all happened. I mean, from its first launch in late 2024 to being adopted by the Linux Foundation and then Microsoft Copilot just over a year later, the journey for MCP to become the common language of AI was unbelievably quick.
So, where does this all go from here? Well, the road ahead points to things like self-healing systems, where AIs can find and fix problems in our software without a human ever getting involved. We're starting to see the beginnings of multi-agent societies, where you have teams of different specialized AIs working together. And we're getting closer to true agent portability, where your personal AI can just follow you from your phone to your car to your laptop seamlessly.
And if there's one thing to take away from all of this, it's this idea right here. The whole paradigm is changing. The future isn't about building a slightly smarter chatbot. It's about building capable, autonomous agents that can actually act on our behalf, safely and reliably, out in the real world.
That wraps up our deep dive into the architecture of autonomy. If you're ready to start building your own connected agents, we've added links to the frameworks mentioned, like VastMCP for Python and the official TypeScript SDK, in the description below. If this gave you a bit more clarity, or if it expanded your own context window, please share this with someone else who loves a good rabbit hole. We're building this channel on your curiosity, so if you have advice on how we can improve or a specific topic you want us to feed into the engine next, drop a comment below. Like and subscribe, and we'll see you in the next one.